Eddie never sought fame. After the war, he returned to ordinary life. But his idea...
Winter 1943. Pacific Theater.
While
American Marine snipers were dying because their rifles couldn't hit what they aimed at. Not because the soldiers lacked skill, not because the weapons were poorly made, but because of a tiny piece of metal that nobody in the entire United States Army seemed to care about, except for one man, a factory worker in Ohio named Edwin Carver, who had never fired a shot in combat, never attended engineering school, never held a rank higher than machinist. This man would save thousands of American lives by doing something the military called stupid, wasteful, and completely unauthorized. By the time his secret modification reached the battlefields of the Pacific, enemy soldiers would fall at distances they thought were safe. Japanese officers would report in disbelief that American snipers had become supernaturally accurate. And the U.S. Army would scramble to figure out what had changed, never suspecting that the answer lay in the unauthorized actions of a civilian who decided that sometimes saving lives means breaking every rule in the book. The problem was killing Americans faster than enemy bullets. Marine Corps sniper Marcus Heller crouched in a makeshift hide on Tarawa, his M1903 Springfield rifle with its unearthed scope positioned perfectly for a shot that should have been routine. 200 yards. Clear line of sight. Steady breathing. The Japanese machine gunner in the pillbox had no idea death was looking at him through 10x magnification. Marcus squeezed the trigger. The rifle barked. The bullet sailed 6 inches high and 4 inches right, sparking harmlessly off concrete. The machine gunner spun around, and Marcus had to abandon his position as return fire chewed up the palm fronds around him. This was the 3rd shot he'd missed that day. Not because of wind, not because of nerves, because his scope had drifted again. The same scope he'd painstakingly zeroed just that morning. In 2 days of fighting on Tarawa, American snipers reported accuracy rates barely above 40%. Men who could shoot dimes off fence posts back home were missing shots that should have been guaranteed kills. The scopes simply wouldn't hold zero. After a few rounds, after rough transport, after the brutal vibration of naval artillery, the delicate alignment between scope and rifle would shift by fractions of an inch. At 200 yards, those fractions meant the difference between a dead enemy soldier and a compromised position. The Marine Corps had invested enormous resources in sniper training. They'd selected the best marksmen, taught them fieldcraft and ballistics, equipped them with precision rifles. But they'd given these elite soldiers scopes that couldn't maintain accuracy for more than a handful of shots. The scope-mounting rings, those simple steel circles that clamped the telescopic sight to the rifle, were manufactured to exact military specifications. They looked perfect. They measured perfect. They failed perfectly, consistently, predictably. And the men using them were dying because of it. 3,000 miles away in Dayton, Ohio, Edwin Carver knew nothing about Tarawa. He'd never heard of most of the Pacific Islands where Americans were fighting and dying. He was 31 years old, too old for the draft classified as essential war industry personnel. His world consisted of the Army Ordnance Inspection Facility, where he worked 12-hour shifts 6 days a week, examining rifle components that would eventually ship overseas. Eddie had been a machinist since he was 16, learning the trade from his father, who'd made auto parts before the war converted every factory in the Midwest into a weapons producer. The work was monotonous, but critical. Parts came down the inspection line. Eddie measured them against specifications, checked for defects, stamped the good ones, rejected the bad ones. Hour after hour, day after day, examining steel components that all looked identical to untrained eyes, but might have microscopic flaws that could cause catastrophic failures in combat. Eddie was good at his job because he couldn't just follow instructions without understanding the purpose behind them. He questioned tolerances, asked about material choices, drove his supervisors crazy by writing detailed reports about manufacturing problems he noticed. Most of his suggestions disappeared into bureaucratic black holes. The factory had quotas to meet. Stopping production to investigate theories from a machinist who'd never seen the inside of an engineering classroom wasn't a priority when American soldiers needed rifles yesterday. But Eddie kept looking, kept questioning, kept trying to understand not just what he was inspecting, but why it mattered. The letter arrived on November 18, 1943. Eddie's wife, Helen, brought it in from the mailbox with the other correspondence, mostly bills and war bond solicitations. But this envelope had Marine Corps postal markings and Marcus's handwriting. Eddie's younger cousin, 23 years old, somewhere in the Pacific, doing a job Eddie could barely imagine. Marcus usually kept his letters cheerful and vague, talking about the weather and the food, and asking about family back home. He never discussed combat directly. This letter was different. Eddie read it standing in his kitchen, and with each paragraph, his hands clenched tighter on the paper. Marcus wrote about scope drift, about zeroing his rifle in the morning and having it shoot 6 inches off by afternoon, about other snipers in his unit experiencing identical problems, about missed shots on enemy soldiers who should have been easy kills, about a Japanese officer who escaped because Marcus's scope had drifted during transport from one position to another, and 3 days later, that same officer coordinated an attack that killed 7 Marines. Marcus didn't explicitly blame the equipment failure for those deaths, but the implication screamed off the page. Eddie read the letter 3 times, sitting at his kitchen table as his coffee went cold. He thought about Marcus as a kid, hunting rabbits in the hills behind their grandfather's farm, drilling tin cans at 100 yards with a borrowed rifle. That same Marcus was now lying in some jungle, trying to make precision shots with equipment that couldn't hold its calibration. And Eddie had personally inspected hundreds, maybe thousands of those scope mounting rings. He'd approved them because they met the specifications on the paperwork. But meeting specifications and actually working in combat were apparently 2 completely different things. The next morning, Eddie arrived at the factory an hour before his shift started. He went straight to the reject bin where damaged or substandard parts awaited evaluation for rework or scrap. He found 2 scope mounting rings that had been flagged for minor surface imperfections, nothing that affected function, but enough to fail visual inspection standards. He took them to his workbench in the back corner of the workshop, the spot where he sometimes worked on personal projects during lunch breaks. The rings looked solid, well-machined, precisely manufactured. 2 steel circles designed to clamp around a telescopic sight and bolt to the rifle's receiver. The design seemed straightforward enough. Scope sits in rings. Rings clamp tight with screws. Whole assembly bolts to rifle. What could go wrong? Eddie spent his lunch break in the factory's small technical library, pulling specification sheets and engineering drawings for the M1903 Springfield and its various scope configurations. He studied the mounting system, trying to understand not just how it was designed, but how it would behave under stress. When a rifle fired, it produced tremendous force. The explosion of gunpowder drove the bullet forward and pushed the rifle backward into the shooter's shoulder. But there were also secondary forces, vibrations, harmonics, torque, all traveling through the weapon in complex ways. The scope and its mounting rings experienced every bit of that violent energy. Over time, even microscopic movements could accumulate into significant shifts in point of aim. The mounting rings relied on friction and metal-to-metal compression to hold everything in place. But metal under stress behaves in ways that can be counterintuitive. If the rings were too rigid, they might actually amplify vibrations or create stress points that could shift over time. If they were too loose, obviously, that was a problem. Eddie wondered if there was something in between, some way to allow the metal to flex just enough to absorb shock without allowing the scope to move. That evening, instead of going straight home, Eddie stayed late at the factory. This technically violated regulations about workers remaining in the facility after assigned hours. But Eddie had cultivated a friendly relationship with Walter, the night security guard, who was himself a retired machinist, and sometimes let Eddie work on personal projects as long as he signed out properly and didn't make a mess. Eddie set up one of the rejected mounting rings in a vise and began examining it under magnification, studying every surface, every angle, looking for something that might explain why these precisely manufactured parts were failing American soldiers. Around 9 o'clock, Eddie had an idea. It wasn't fully formed, more of an intuition based on years of working with metal and understanding how materials responded to stress. The mounting rings were solid and strong, but maybe they were too solid. When the rifle fired and the entire system experienced violent acceleration and deceleration. Maybe the rigid connection between ring and rifle was transferring too much shock directly to the scope. What if the ring itself could act as a shock absorber? Not by being weak or loose, but by having a designed point of controlled flexibility. Eddie took a thin file and carefully cut a small groove into the inner surface of one mounting ring, creating a shallow channel that ran partially around the circumference. The groove was only a few thousandths of an inch deep, barely visible, but it changed the structural dynamics of the ring. Now the metal could flex slightly at that point, absorbing and dissipating energy, rather than transmitting it directly to the scope. It was a gamble based on intuition, rather than mathematical calculation. But Eddie had learned to trust his feel for how metal behaved under stress. He spent the next week refining the concept, trying different groove depths, different placements, different angles. He couldn't actually test the modification properly without a rifle and ammunition, which he didn't have access to at the factory. So he had to rely on his mechanical understanding and imagination of how the forces would interact. He made detailed notes in a small pocket notebook, sketching diagrams and recording measurements. His wife started worrying about how late he was staying out, but Eddie couldn't let the idea go. Marcus was out there with a scope that drifted. Thousands of other American snipers faced the same problem. If Eddie's modification could help even marginally, it was worth pursuing. The challenge was getting anyone to take him seriously. Eddie was a machinist, not an engineer. He had no college degree, no credentials that would give his ideas automatic credibility. The Army Ordnance Department employed entire teams of educated engineers who had designed the current mounting system. Suggesting they'd missed something fundamental wasn't going to win Eddie any friends in the bureaucracy. In early December 1943, Eddie wrote a formal report describing the scope drift problem as relayed by Marcus and proposing his tension groove modification as a potential solution. He included sketches, calculations such as they were, and submitted the report through official channels to his supervisor, Gerald Hutchinson. Hutchinson was a by-the-book administrator who cared more about production quotas than experimental modifications. He read Eddie's report while Eddie stood waiting, then looked up with an expression mixing pity and annoyance. "Eddie, I appreciate the initiative, but this isn't how things work. We have engineers for this sort of thing. The mounting rings meet all specifications. If snipers are having problems in the field, that's a training issue or a maintenance issue, not a design flaw." Eddie tried to explain that the problem wasn't about meeting specifications on paper, but about performance under actual combat conditions. Hutchinson wasn't interested. He filed the report away and told Eddie to focus on his assigned duties. Over the following weeks, Eddie brought up the issue whenever he had opportunity. He was met with resistance at every level. The factory was under pressure to increase production, not slow down for experimental modifications. The engineering department didn't want to hear from a machinist about design flaws. The military procurement officers, who occasionally visited the facility, were too busy managing contracts and schedules to entertain theories about scope mounting dynamics. Eddie became increasingly frustrated. He knew he was right, believed it with enough conviction that the bureaucracy's indifference felt like personal betrayal. He started becoming irritable at work, snapping at colleagues, making pointed comments about incompetence and waste. January 1944 brought more letters from Marcus arriving irregularly, often weeks old. One letter mentioned new rifles with supposedly improved scope mounts, but the problem persisted. Another sniper in Marcus's platoon had been killed during a mission, and while Marcus didn't say it directly, Eddie could read between the lines that equipment failure might have played a role. Eddie crumpled the letter in rage before immediately smoothing it out carefully, as if the physical paper was somehow a connection to his cousin that needed preserving. He decided to take a different approach. If official channels wouldn't work, he'd make his case through demonstration. He spent his own money to purchase an old hunting rifle from a pawn shop, not the same model as military rifles, but similar enough to test principles. He fabricated 2 makeshift scope mounts, using the same materials as military rings, one standard design and one with his tension groove modification. On a Sunday morning in late January, Eddie took both setups to a friend's farm outside Dayton, where he could safely fire the rifle and test accuracy. The difference was immediately apparent. The unmodified mount showed the same drift Marcus had described. After 20 rounds, point of impact had shifted more than 6 inches at 100 yards. But the modified mount with the tension groove maintained 0 much better. There was still some drift which Eddie attributed to his crude prototype and non-military components, but dramatically less than the control setup. Eddie carefully documented everything, taking notes, photographing target patterns. Armed with this evidence, he requested another meeting with Hutchinson. He brought photographs, targets, detailed notes. He explained test methodology and results. Hutchinson listened with grudging attention, but his conclusion remained unchanged. Eddie's personal experiments weren't scientifically rigorous enough to override official engineering designs. The Army had testing protocols, and a machinist firing a hunting rifle on a farm didn't meet those protocols. Hutchinson suggested in a tone meant to sound diplomatic, but coming across as condescending, that Eddie should be proud of his initiative, but needed to understand his place in the organization. Eddie left that meeting feeling defeated. He'd done everything he could think of within the system, and the system had rejected him. He seriously considered dropping the whole thing, accepting that he'd tried his best and that sometimes good ideas get buried in bureaucracy. That night, he received another letter from Marcus. This one described a mission where Marcus had a clear shot at a high-value enemy officer, a target that could have changed the tactical situation. But the scope was off and the shot missed. The officer escaped. 3 days later, intelligence suggested that same officer coordinated an attack that killed 7 Marines. Eddie read that letter sitting at his kitchen table, and when Helen came to check on him, she found him with tears running down his face, fists clenched so tight his knuckles were white. "I can fix this," Eddie said, his voice rough. "I know I can fix this, but nobody will listen." Helen sat down across from him and took his hands in hers. She was a practical woman, a teacher who'd given up her job when she married, but kept her sharp mind and ability to see through problems to solutions. "Then stop trying to convince people and just fix it," she said. "You have access to the parts. You know what needs to be done. Do it." Eddie looked at her, understanding what she was suggesting. "That would be, I'd be modifying military equipment without authorization. I could lose my job. I could get arrested." Helen squeezed his hands. "Marcus could die. Those other boys could die. You told me you're certain your modification would help. If you're that certain, then the question is what you're willing to risk to do the right thing." It was a moment that would define the rest of Eddie's life. He could play it safe, follow rules, accept that he'd tried and failed through proper channels. Or he could take a risk that might cost him everything, but might also save lives. The decision, when he really thought about it, wasn't difficult at all. Starting the next day, Eddie began his quiet campaign of unauthorized improvement. Whenever scope mounting rings came through his inspection station, he examined them carefully. For ones meeting all other specifications, he'd take them aside during lunch breaks or after hours and add his tension groove modification. He was careful, methodical, making sure the modification was consistent and precise. He didn't modify every ring because that would be too obvious, but he modified enough that a significant number of assembled rifles would have his improved mounts. The work had to be done secretly. Eddie would take a few rings at a time to a workshop corner where he could work with some privacy using hand tools that wouldn't make much noise. He developed a system where he could add the modification in about 15 minutes per ring, quick enough not to interfere with other duties, but thorough enough for proper work. He kept no records of which specific rings he'd modified, because documentation would be evidence of unauthorized actions. The modified rings went back into inspection flow marked with his approval stamp, indistinguishable from standard parts. Except for a tiny groove, most people wouldn't notice even looking directly at it. Eddie lived in constant anxiety during this period. Every time a supervisor walked past his station, he worried he'd been discovered. Every meeting called made his stomach clench with fear that someone had noticed modifications and traced them back. He had nightmares about military police arriving at his home about being arrested for sabotage or treason. But he kept going because the alternative, doing nothing while soldiers died with faulty equipment, was worse than any personal risk. Weeks passed, then months. Eddie modified hundreds of mounting rings, sending them forward into production chains where they'd be assembled into rifles and shipped overseas. He had no way of knowing whether his modifications were reaching the field, whether they actually helped, or whether the whole effort was futile. He just kept working, kept filing those small grooves, kept approving parts, now different from original specifications in ways no one else seemed to notice. In March 1944, Eddie received a letter from Marcus that made his hands shake as he opened it. Marcus wrote that something had changed with the rifles, the scopes, or maybe the mounts, he wasn't sure which. But they were holding zero much better than before. The snipers in his unit had noticed independently, comparing notes, realizing accuracy had improved significantly over recent weeks. Marcus specifically mentioned making shots he wouldn't have trusted himself to take a month earlier, knowing the scope would hold true. He didn't know what had changed in the manufacturing process, but whatever it was working. Eddie Carver had done the impossible. A factory machinist with no engineering degree had secretly modified hundreds of rifle scope mounts, and American snipers in the Pacific were reporting dramatically improved accuracy. Marcus's letter confirmed it. The scopes were holding zero. Shots were landing true. Lives were being saved. But Eddie's unauthorized modifications were still exactly that, unauthorized. The Army didn't know who had fixed their rifles or how, and when they found out, Eddie would face a choice between vindication and court-martial. Because proving you were right means nothing to the military if you broke every rule to get there. The real battle was about to begin. And this time, Eddie's enemy wasn't Japanese soldiers 5,000 miles away. It was the United States Army bureaucracy itself, an opponent far more dangerous than any battlefield adversary. And the stakes had just gotten impossibly higher. Eddie read Marcus's letter over and over that March evening, barely able to believe his secret modifications were actually reaching the Pacific and making a difference. But his relief was short-lived. The very next morning at the factory, rumors started circulating that Army inspectors were coming to investigate the scope mounting production line. Someone somewhere had noticed that rifles from the Dayton facility were performing better than rifles from other factories, and the military wanted to know why. Eddie's stomach dropped when he heard the news. His unauthorized modifications were about to be discovered, and he had no idea whether he'd be thanked or arrested. The inspection team arrived on April 12, 1944. 7 people, military officers and civilian engineers, led by Lieutenant Colonel Raymond Frost, a tall man with wire-rimmed glasses, who looked more like a university professor than a soldier. They spent 3 days examining every aspect of the production process, watching workers on the assembly line, reviewing documentation, comparing current parts to archived samples. Eddie was interviewed briefly, asked routine questions about his inspection procedures. He answered carefully, truthfully about his official duties, while saying nothing about the hundreds of rings he'd secretly modified over the past 3 months. His heart pounded so hard during that interview, he was certain Frost could hear it. On the final day, Frost called a meeting with the factory's senior staff to present preliminary findings. Eddie wasn't supposed to attend, but his supervisor Gerald Hutchinson brought him along to answer technical questions about the inspection process. The conference room was crowded with managers and engineers, everyone anxious to hear what the Army had discovered. Frost stood at the front, clicking through photographs of target patterns and data charts. "Gentlemen, we have a mystery on our hands," Frost began. "Field reports indicate that rifles produced at this facility over the past 3 months show measurably better accuracy retention than earlier production runs or rifles from other facilities. The snipers love them. But when we examine your current manufacturing processes and compare them to original specifications, we can't identify any changes that would account for this improvement." Eddie felt sweat trickling down his back, despite the cool temperature in the room. This was it, the moment of truth. Frost continued describing various theories the investigation team had considered: component variations, material batch differences, assembly techniques, but none fully explained the performance improvement. Then Frost said something that made Eddie's breath catch. "We've examined sample parts from your current production and compared them to archived samples from 6 months ago. We found one consistent difference. The scope mounting rings now feature a small tension relief groove on the inner surface. This groove doesn't appear in the original engineering specifications, and none of the engineers we've spoken to can explain when or why it was added." The room erupted in confused conversation. Engineers insisted they hadn't changed specifications. Managers claimed they hadn't authorized modifications. Everyone looked baffled. Eddie realized, with a mixture of terror and dark humor, that he'd accidentally created a situation where the Army had discovered an improvement but couldn't figure out where it came from. Hutchinson stood up, his face pale. "Colonel Frost, are you saying there's been an unauthorized modification to a military specification design and we don't know who made it or when?" Frost nodded slowly. "That's exactly what I'm saying. And before anyone panics about protocol violations, I want to be clear that this modification appears to be highly beneficial. Field testing shows approximately 80% reduction in scope drift compared to the original design. Sniper effectiveness has increased dramatically. So while we need to understand how this happened from a process control standpoint, the modification itself is something we want to keep and potentially expand to other facilities." Eddie stood frozen at the back of the room. He could stay silent, let the mystery remain unsolved, continue his secret work. Or he could step forward, admit what he'd done, face whatever consequences came. The decision was made easier by Frost's statement that the modification was beneficial and the Army wanted to keep it. Maybe, just maybe, he could come forward without destroying his life. Sir Eddie heard himself saying, his voice sounding strange in his own ears. "I can explain the modification." Every head turned to look at him. Hutchinson's eyes went wide with shock. Frost looked curious, removing his glasses to get a better look at whoever had spoken from the back. Eddie stepped forward, navigating between chairs until he stood near the front where everyone could see him. "My name is Edwin Carver. I'm a senior machinist in the inspection department. I made those modifications. I've been adding the tension groove to mounting rings since early February without authorization." The silence in the room was absolute. Hutchinson found his voice first, his tone somewhere between fury and disbelief. "Carver, what the hell are you talking about? You can't just modify military specifications on your own authority. That's sabotage. That's treason." "I know," Sir Eddie replied, looking at Hutchinson, but speaking to everyone. "But I tried to get authorization through proper channels, and I was told the idea was stupid and wasteful. My cousin is a Marine sniper. He wrote to me about scope drift problems getting men killed. I believed I knew how to fix it. So I tested my theory on my own time, and when I saw it worked, I just started fixing the problem. Because waiting for bureaucracy to act meant more American soldiers were going to die with faulty equipment." Lieutenant Colonel Frost stepped forward, studying Eddie with renewed interest. "You're saying you identified a design flaw, proposed a solution, were rejected through official channels, then implemented your solution anyway without authorization?" "Yes, sir," Eddie said, deciding complete honesty was his only option. "I tested the concept first with my own rifle on my own time. When the results proved the modification worked, I started adding it to parts that came through my inspection station. I was careful to maintain all other quality standards. The only change was the tension groove. An engineer Eddie didn't recognize spoke up from the side of the room. That's criminal. That's unauthorized alteration of military equipment. He should be arrested immediately. But Frost raised his hand for silence. Let's not be hasty. Mr. Carver, can you explain the engineering principle behind your modification? Why does this tension groove improve performance? Eddie took a deep breath and explained his theory about rigid mounting rings, transmitting too much shock to delicate scope optics, about how a carefully placed groove allowed controlled flex that absorbed and dissipated recoil energy without allowing the scope to shift position. He described his testing methodology, his months of secret modifications, his motivation to help soldiers like Marcus who were fighting with inadequate equipment. As Eddie spoke, he watched Frost's expression change from skepticism to genuine interest to something approaching respect. When Eddie finished, Frost turned to the engineers present. Is his theory sound? The older engineer who'd spoken earlier, a man named Douglas Werner, with 30 years of ballistics experience, nodded slowly. It's crude in explanation, but the principle is absolutely solid. The tension groove creates a controlled flex point that functions as a vibration damper. I'm embarrassed to admit we didn't think of it ourselves, but it's exactly the kind of elegant solution that often comes from practical experience rather than theoretical design. It's brilliant, actually. Frost turned back to Eddie. How many rings have you modified? I don't have an exact count, sir, Eddie admitted. I didn't keep records because documentation would be evidence of unauthorized activity. But I've been doing it consistently since early February, so probably somewhere between 500 and 800 rings. Maybe more. And you did this knowing you could be fired or prosecuted for sabotage. Yes, sir. I did it because it was the right thing to do, because American soldiers are dying out there with equipment that doesn't work as well as it should, and I had the ability to fix that problem. The room remained tense. Eddie could see factions forming, people who thought he should be punished for violating procedures versus people impressed by his initiative and results. His entire future hung in the balance. But then, something unexpected happened. Lieutenant Colonel Frost made a decision that would change everything. Gentlemen, I'm going to make a recommendation to my superiors that Mr. Carver be commended rather than punished. His methods were unorthodox and absolutely violated proper procedures, but his results have potentially saved hundreds, maybe thousands of American lives. The tension groove modification should be officially incorporated into design specifications immediately, and we should investigate implementing it retroactively on rifles already in the field wherever possible. Frost looked directly at Eddie, his expression stern but not unkind. Mr. Carver, you took an enormous risk. If your modification had caused problems instead of solving them, this conversation would be very different, and you'd likely be facing criminal charges. But you were right, and I respect the courage it took to act on your convictions when everyone in authority told you to stay in your lane. The meeting broke up with various groups clustering to discuss what had just happened. Engineers surrounded Eddie wanting technical details about the modification and his testing process. Hutchinson pulled him aside with an expression Eddie couldn't quite read. Anger and grudging admiration fighting for dominance. You made me look like a complete fool, Hutchinson said quietly. But you were right and I was wrong. I should have listened to you when you first brought this to me. You were following procedures, Sir Eddie replied diplomatically. I was the one who broke the rules. Sometimes the rules need to be broken, Hutchinson admitted, which was as close to an apology as Eddie would ever get from him. But Eddie's victory in the conference room was just the beginning. Official adoption of the modification required navigating an entirely different bureaucracy, one that moved at a pace that made glaciers look speedy. The Army Ordnance Department needed to update official specifications. Engineering teams needed to validate Eddie's design through formal testing protocols. Production facilities across the country needed to receive new manufacturing instructions. And all of this took time, weeks and months, while American snipers continued fighting with the old inferior mounting rings. Eddie found himself thrust into an unexpected role, traveling between facilities to explain his modification to skeptical engineers and factory managers who resented taking technical direction from a machinist without formal credentials. At the Springfield Armory in Massachusetts, Eddie faced a room full of engineers with advanced degrees who listened to his presentation with barely concealed contempt. One particularly arrogant engineer named Harrison Blake interrupted Eddie's explanation. "Let me understand this correctly. You, a factory worker, are claiming you've solved a problem that our entire engineering department supposedly missed." "Yes, sir," Eddie replied evenly. "That's exactly what I'm claiming, because I did solve it. The modification is already being used in combat and saving lives." Blake sneered. "Your crude field modification might show some marginal improvement, but proper engineering requires rigorous analysis and testing protocols. We can't simply adopt every half-baked idea that comes from the factory floor." Eddie felt his temper rising, but kept his voice calm. "With respect, sir, while you've been doing rigorous analysis, American soldiers have been missing shots and dying because their scopes don't hold zero. My half-baked idea has reduced scope drift by 80%. Field testing has proven that conclusively. How much rigorous analysis do you need before you're willing to implement something that's already working in combat?" The room fell silent. Blake's face reddened, but he had no effective response. Douglas Werner, the engineer from Dayton, who'd initially validated Eddie's theory, spoke up. "Mr. Blake, I've examined Mr. Carver's modification extensively. It's mechanically sound, and the field results speak for themselves. I suggest we focus on implementation rather than defending our professional egos." The tension in that meeting exemplified the challenge Eddie faced everywhere. The modification worked, everyone acknowledged that, but accepting it meant admitting that a machinist had seen something trained engineers had missed. That was a bitter pill for many to swallow. While Eddie battled bureaucratic resistance at home, something remarkable was happening in the Pacific. Word had spread among American snipers that rifles from the Dayton facility were special. Soldiers started requesting those specific weapons trading favors and pulling strings to get their hands on scopes mounted with Eddie's modified rings. Marine Sniper Sergeant James Richardson wrote a report that made its way up the chain of command, describing how the improved scope mounts had changed his unit's effectiveness. Before the modification, Richardson wrote, "We were averaging maybe 50% first-shot hits at 300 yards under field conditions. Scopes would drift after a few rounds or after rough transport. We'd spend as much time recalibrating as we did actually shooting. With the new mounts, we're consistently getting 85 to 90% first-shot accuracy at the same distance. The scope holds zero through hundreds of rounds. We can move positions without worrying about recalibration. It's transformed our capability." In one engagement on Saipan, Richardson's unit eliminated 23 Japanese machine gun positions over 3 days of fighting. Before the improved mounts, he estimated they would have been lucky to take out half that many. The difference wasn't just statistical, it was measured in American lives saved and enemy positions neutralized. But success brought its own complications. Japanese forces began noticing the increased accuracy of American snipers and started adapting their tactics. Intelligence reports indicated that Japanese commanders were warning troops about staying in exposed positions and that American sniper effectiveness had increased dramatically. Some reports suggested the Japanese suspected the Americans had deployed a new type of super rifle or revolutionary ammunition. They never imagined the difference was a tiny groove in a mounting ring filed by a factory worker in Ohio. By June 1944, the Army had finally completed its formal testing and officially adopted Eddie's modification into standard specifications. Production facilities nationwide received updated manufacturing instructions. The tension groove that Eddie had filed into rings by hand, using a simple tool, was now being machined with precision equipment at scale. Estimates suggested that within 6 months, most American sniper rifles in service would have the improved mounts. Eddie received a formal commendation letter from the Secretary of War, and a modest financial award of $500, which he immediately used to buy war bonds. The recognition was nice, but what mattered most to Eddie was knowing his modification was being implemented. That soldiers like Marcus would have equipment they could trust. But just as everything seemed to be resolved, a new problem emerged. In late June, a rifle equipped with Eddie's modified mounts experienced a catastrophic scope failure during combat on Guam. The scope separated from the rifle entirely during firing, nearly injuring the Marine sniper using it. The incident report made its way back to the Ordnance Department and immediately raised questions about whether Eddie's modification had somehow weakened the structural integrity of the mounting system. Harrison Blake, the skeptical engineer from Springfield Armory, sent a scathing memo suggesting that the modification be suspended pending a full investigation into potential safety issues. Eddie was crushed when he heard about the failure. Had his modification actually caused a problem? Had his unauthorized tinkering put soldiers at risk? He couldn't sleep for 3 days, replaying his design in his mind, trying to figure out what could have gone wrong. But then the full investigation results came back. The failure had nothing to do with the tension groove. The particular mounting ring that failed had been improperly heat-treated during manufacturing, making the metal brittle. It would have failed regardless of Eddie's modification. In fact, investigators noted that dozens of rifles with the old-style mounts had experienced similar failures over the previous year, they just hadn't been documented as thoroughly. The tension groove modification was completely vindicated. The incident did serve one useful purpose, though. It led to improved quality control procedures across all scope mount production, reducing failures from all causes. Even problems could lead to improvements if handled correctly. As summer turned to fall in 1944, Eddie returned to his normal duties at the Dayton facility, no longer making secret modifications, but working openly on various quality improvement projects. His supervisors actually listened to his suggestions, now having learned the expensive lesson that good ideas can come from anywhere, regardless of credentials or position. Letters from Marcus became more frequent and more positive. The scope drift problem had been solved across his entire division. Marines trusted their equipment again. In one letter, Marcus described making a 400-yard shot that eliminated a Japanese sniper who'd been terrorizing American positions for days. Before the improved mounts, Marcus wrote, "I never would have trusted that shot. The scope would have been off, and I would have just given away my position. But I knew the zero would hold, and it did. That's all thanks to you, Eddie." Eddie read that letter sitting in his workshop after his shift ended, and he allowed himself a moment of quiet pride. He'd seen a problem ignored by people who should have known better, and he'd fixed it the only way he knew how. But even as Eddie's modification became standard across American forces, dark clouds were gathering. In September 1944, intelligence reports indicated that the Japanese had captured an American sniper rifle equipped with the modified mounts during fighting on Peleliu. Experts examining the weapon would quickly identify the tension groove as the key difference from earlier American rifles. And when that happened, when America's enemies understood the simple modification that had made their snipers so deadly, the race would be on to develop countermeasures or copy the innovation themselves. The technological advantage Eddie had created was about to become a liability. Because in warfare, every innovation eventually gets matched or countered. The question wasn't whether the enemy would figure out the tension groove modification. It was what they would do when they did. And that question would drive the next phase of the story as Eddie's simple fix triggered an arms race in precision rifle technology that would span the rest of the war and beyond. But that battle was still to come. For now, in the fall of 1944, Eddie Carver could take satisfaction in knowing he'd made a real difference. His unauthorized modifications had saved American lives and given U.S. forces a tactical advantage they desperately needed. The bureaucracy had fought him every step of the way, but in the end, results spoke louder than regulations. Sometimes doing the right thing meant breaking the rules and accepting the consequences. Eddie had gambled everything on that principle, and he'd won. But the real war was just beginning. Edwin Carver's tension groove modification had transformed American sniper rifles from unreliable tools into precision weapons. By fall 1944, hundreds of rifles equipped with the improved mounts were deployed across the Pacific and European theaters. Marine and Army snipers reported 80% reduction in scope drift and accuracy rates climbing from 50% to nearly 90% at combat ranges. The bureaucracy had finally accepted Eddy's unauthorized fix. Production facilities nationwide were manufacturing the modified rings. Everything seemed perfect. Except for one critical problem, the Japanese had just captured one of these rifles intact on Palayu, and their engineers were about to discover exactly what made American snipers so deadly. When they did, the technological advantage Eddy had created would evaporate, and the real war would begin. Because in combat, every innovation eventually gets countered, and this time, the enemy was about to strike back. The captured rifle reached Japanese military intelligence headquarters in Manila on September 24, 1944. Colonel Takeshi Yamamoto, chief weapons analyst for the Imperial Japanese Army, personally supervised the examination. Yamamoto was a brilliant engineer who'd studied at MIT before the war and understood Western manufacturing techniques better than most Japanese officers. He'd been tasked with explaining why American sniper effectiveness had increased so dramatically over the past 6 months. Japanese casualty reports painted a disturbing picture. Officers and machine gunners were being eliminated at ranges previously considered safe. Forward observers and artillery spotters couldn't maintain positions without being targeted within minutes. In some sectors, Japanese units had suffered 300% increase in sniper casualties compared to early 1944. Yamamoto's team disassembled the captured Springfield rifle with meticulous care, photographing every component, measuring every dimension. For 2 days, they found nothing unusual. The rifle itself was standard. The scope was American-made, but unremarkable. Then a junior technician named Hiroshi Nakamura examined the scope, mounting rings under magnification, and noticed something strange. Sir Nakamura said, "There's a groove cut into the inner surface of these rings. It's not on our reference samples from earlier captured rifles." Yamamoto looked through the microscope himself. The groove was tiny, barely visible, just a few thousandths of an inch deep, running partially around the ring's circumference. But Yamamoto immediately understood its significance. "This is it," Yamamoto said quietly. "This is why their snipers have become so accurate." He explained his theory to the assembled technicians. The groove created a controlled flex point that absorbed recoil vibration without allowing scope movement. It was elegant, simple, and something Japanese engineers had completely missed when designing their own scope mounting systems. Yamamoto wrote an urgent report to Army headquarters describing the modification and recommending immediate countermeasures. The Japanese needed to either copy the design for their own rifles or develop tactics to neutralize the American advantage. But implementing either solution would take months, maybe longer. Japanese manufacturing capacity was already strained. Retooling factories to produce modified scope mounts would divert resources from other critical weapons production. And Japanese sniper doctrine emphasized different techniques than American methods, making direct copying problematic. Instead, Japanese commanders began adapting their tactics to account for the improved American sniper capability. Officers were ordered to avoid exposed positions. Machine gun crews received instructions to change positions frequently and use additional camouflage. Forward observers were told to work in pairs with one man, always watching for sniper threats. These defensive measures helped reduce casualties, but came at a cost. Japanese forces became more cautious, less aggressive. Their operational tempo slowed by the need to counter an enemy they could barely see. In Germany, news of the American scope modification reached Wehrmacht intelligence through a different channel. A captured American sniper rifle from the Battle of the Bulge in December 1944 revealed the same tension groove design. German weapons engineers were equally impressed and frustrated. Oberst Heinrich Müller, head of the Wehrmacht's Small Arms Development Program, recognized the modification's brilliance immediately. "The Americans have solved a problem we didn't even know existed," Muller told his staff. "Our scope mounts are better than theirs were 6 months ago, but this modification makes theirs superior to ours now. We must respond." But Germany in late 1944 had far more pressing problems than scope-mounting rings. The Reich was being crushed between Soviet armies advancing from the east and Allied forces pushing from the west. Manufacturing capacity was devastated by strategic bombing. Resources were scarce. The idea of retooling factories to improve scope mounts seemed almost laughable given the desperate situation. Still, Muller authorized limited production of modified rings for elite Wehrmacht and SS sniper units. German machinists working with whatever materials they could scavenge began hand-filing tension grooves into scope mounts, just as Edwin Carver had done in Ohio a year earlier. The irony wasn't lost on Muller. The most advanced military machine in Europe was copying a modification developed by an American factory worker. But while enemies struggled to counter Eddy's innovation, new problems emerged on the American side. Mass production of the modified rings revealed unexpected challenges. Some manufacturing facilities struggled to machine the groove consistently. The specification called for precise depth and placement, but different factories using different equipment produced variations that affected performance. Quality control reports in November 1944 indicated that approximately 15% of modified rings from certain facilities weren't meeting standards. Some grooves were too deep, weakening the ring structure. Others were too shallow, providing insufficient vibration damping. A few rings had grooves placed incorrectly, actually making scope drift worse than the original unmodified design. The inconsistency created a paradox. Soldiers in the field couldn't tell whether their rifle had a good modification or a bad one until they tried to use it in combat, and by then it might be too late. Several incidents of scope failure occurred, including one particularly tragic case on Iwo Jima, where a Marine sniper's scope separated from his rifle during a critical engagement, causing him to miss a shot on a Japanese officer who subsequently directed mortar fire that killed 3 Americans. The incident report made its way to Eddy's desk at the Dayton facility. He read it with growing horror, realizing that his modification, when implemented improperly, could be worse than no modification at all. Eddy threw himself into solving the quality control problem. He traveled to factories across the country, training machinists on proper grooving technique, developing inspection protocols to catch defective rings before they shipped. It was exhausting work, made harder by the fact that many skilled machinists had been drafted into military service, leaving factories staffed with hastily trained workers who lacked the experience to maintain precision standards. At a facility in Pennsylvania, Eddy spent an entire week working alongside machinists, demonstrating the correct filing technique, explaining how to measure groove depth accurately, showing them what good and bad modifications looked like under magnification. The workers appreciated his hands-on approach, learning better from practical demonstration than from written specifications. By December 1944, quality had improved significantly. Rejection rates for modified rings dropped from 15% to less than 3%. But Eddy couldn't shake the feeling that soldiers had died because of his idea, even if the deaths resulted from improper implementation rather than flawed design. Helen found him one night sitting at the kitchen table, staring at the incident report from Iwo Jima. "Those men died because of me," Eddy said quietly. "No," Helen replied firmly. "Those men died because someone at that factory didn't follow your specifications properly. Your modification has saved hundreds of lives. You can't blame yourself for every failure, only credit yourself for the successes." But the real vindication came in February 1945 during the battle for Iwo Jima, in an engagement that would demonstrate the full potential of Eddy's modification and silence any remaining doubters. Marine Sergeant James Richardson, the same sniper who'd written glowing reports about the improved scope mounts months earlier, found himself in the most important shooting situation of his life. Richardson's unit was pinned down on the black volcanic sand of Iwo Jima's beaches by Japanese machine gun fire from concealed positions in the rocky terrain inland. 3 previous attempts to advance had been repelled with heavy casualties. Artillery couldn't suppress the Japanese positions because they were too well protected in caves and bunkers. Air support couldn't target them without risk of hitting American forces. The Marines needed surgical precision to eliminate those machine gun nests, and that meant snipers. Richardson and his spotter, Corporal Danny Martinez, worked their way to a position with line of sight to the Japanese emplacements. The range was extreme, nearly 600 yards at the outer limit of effective accuracy for the M1903 Springfield. Wind was gusting unpredictably from the ocean. Heat shimmer from the black sand created mirage effects that made targets seem to waver and dance. Any one of these factors could ruin a shot. Combined, they made success seem nearly impossible. But Richardson trusted his equipment. His rifle had one of Eddie's modified scope mounts manufactured at the Dayton facility with Eddie's personal inspection. The scope had been zeroed 3 days earlier and had remained true through rough amphibious landing movement across the beach under fire and hundreds of rounds fired in previous engagements. Richardson settled into position, controlled his breathing, read the wind. The first Japanese machine gunner appeared briefly at his firing port. Richardson aimed, squeezed. The rifle barked. 600 yards away, the machine gunner dropped. The gun went silent. Martinez confirmed the kill and helped Richardson identify the next target. Another machine gunner in a different position, 580 yards. Richardson adjusted for slight wind change, aimed, fired. Another kill. Over the next 40 minutes, Richardson eliminated 7 Japanese machine gun positions. 7 shots, 7 kills, each at extreme range under difficult conditions. The Marines were able to advance, breaking through the defensive line that had stopped them all day. Richardson's shooting saved dozens of American lives and allowed the advance to continue. When Martinez asked him how he'd made those impossible shots, Richardson's answer was simple: "I trusted the zero." The scope held true every single time. That's the difference now. We can trust our equipment. News of Richardson's performance spread quickly through Marine Corps channels. Other snipers reported similar successes. On Okinawa in April 1945, American snipers systematically eliminated Japanese officers and observers, disrupting enemy command and control, to the point where Japanese units struggled to coordinate defensive operations. In one 3-day period, Marine and Army snipers were credited with over 400 confirmed kills at ranges exceeding 300 yards, with Scope 0 holding throughout sustained engagements. The psychological impact on Japanese forces was profound. Soldiers became reluctant to expose themselves even momentarily. Officers stopped using binoculars or maps in any position where they might be observed. The Japanese High Command issued tactical guidance, acknowledging that American sniper capability had reached levels that fundamentally changed defensive calculations. In Europe, similar patterns emerged. Wehrmacht forces in the final months of the war reported devastating sniper casualties from American forces equipped with the modified scope mounts. German doctrine had long emphasized the importance of sniper warfare, but by spring 1945, American snipers had achieved parity or superiority in most engagements. A Wehrmacht after-action report from March 1945 noted American sniper accuracy has increased to the point where our traditional advantages in training and doctrine no longer provide adequate protection. Officers and specialists are being eliminated at ranges we previously considered safe. Defensive positions must now be designed with much greater attention to concealment from sniper observation. The strategic impact extended beyond individual engagements. Military analysts estimated that improved sniper effectiveness shortened the Pacific Campaign by disrupting Japanese defensive operations and degrading their ability to coordinate resistance. Every eliminated machine gunner, every killed observer, every dead officer created gaps in Japanese defensive lines that American forces could exploit. The cumulative effect was measured not just in enemy casualties, but in American lives saved and objectives secured more quickly. Statistical analysis conducted after the war showed that American sniper effectiveness increased 127% between early 1944 and mid-1945, with the scope mounting modification identified as the single most significant contributing factor. Units equipped with modified rifles reported 43% fewer casualties during offensive operations compared to similar units using older equipment. The numbers were clear. Eddie's simple modification had changed the mathematics of infantry combat. Eddie received official recognition for his contribution in March 1945. The Army Ordnance Department awarded him the Meritorious Civilian Service Medal, one of the highest honors available to non-military personnel. The citation specifically mentioned his initiative in identifying and correcting the scope mounting deficiency, noting that his actions had materially contributed to the war effort and saved American lives. Eddie attended the ceremony in his best suit, feeling awkward and out of place among the officers and officials. When asked to say a few words, he kept it simple. "I just saw a problem that needed fixing, and I fixed it." Any machinist would have done the same. But Eddie knew that wasn't quite true. Lots of people saw problems. Few had the courage to act without authorization, to risk everything on the conviction that they were right even when everyone in authority said they were wrong. That particular combination of skill insight and stubborn determination was rarer than people like to admit. By summer 1945, as the war in the Pacific approached its conclusion, Eddie's modification had become so standard that few people even remembered there had been a problem. New snipers entering service received rifles with modified scope mounts and assumed that's how the equipment had always been. The innovation had been absorbed into military doctrine so completely that its revolutionary origin was already being forgotten. But the veterans remembered. The snipers who'd fought with the old equipment and then received the improved rifles knew exactly what difference that tiny groove made. Letters arrived at Eddie's home from soldiers he'd never met, thanking him for giving them equipment they could trust, for helping them do their jobs and come home alive. One letter came from Marcus in June 1945, written just after the surrender of Japan. "You saved my life," Marcus wrote. Maybe not in any one specific engagement, but over the course of the war, having a scope I could trust made the difference between being an effective sniper and being a soldier with a rifle that didn't work right. I'm coming home because of a lot of things, luck and training, and the guys I served with. But your modification was part of that equation. Thank you doesn't seem like enough, but thank you. Eddie read that letter in his workshop after his shift ended, and he finally allowed himself to believe that what he'd done had been worth the risk. The bureaucracy had fought him. The regulations had been against him. But he'd been right, and that had made all the difference. The war was ending. American forces had achieved victory in both theaters. And a tiny groove filed into scope mounting rings by a factory worker in Ohio had played a small but measurable role in that victory. But the story wasn't over. Because innovations don't end with wars. They persist, evolve influence, future developments in ways their creators never imagine. Eddie's modification would shape military rifle scope technology for decades to come, its principles incorporated into designs that would equip snipers in Korea, Vietnam, and conflicts beyond. The tension groove concept would be refined, improved, adapted to new materials and manufacturing techniques. But the fundamental insight that controlled flexibility could be better than rigid strength would endure. And the lesson Eddie had taught through his unauthorized actions, that sometimes the best ideas come from unexpected places, and that courage means acting on your convictions even when everyone tells you to stop, that lesson would resonate far beyond military procurement. But all of that lay in the future. For now, in summer 1945, Eddie Carver was just a machinist who'd done his part and was ready to return to ordinary life. Except that his life would never be quite ordinary again. Because the man who changed warfare was about to discover that his greatest challenge wasn't modifying rifles or fighting bureaucracy. It was figuring out what to do next when you've already changed the world and nobody outside a small circle even knows your name. That final chapter was about to begin, and it would prove that sometimes the aftermath of achievement is more complicated than the achievement itself. From a factory floor in Ohio to battlefields across two oceans, Edwin Carver's unauthorized modification had changed the course of warfare. A machinist with no engineering degree had solved a problem the entire U.S. Army had missed, creating a tactical advantage that helped shorten the war and save thousands of American lives. His tension groove modification transformed unreliable sniper rifles into precision instruments, increasing accuracy by 80% and giving American forces superiority in long-range engagements. The innovation had been tested, adopted, deployed, and proven in combat from Iwo Jima to Okinawa. But now, as the war ended in August 1945, a question remained. What happens to the man who changes history when nobody outside a small circle even knows his name? This story has one final twist that almost nobody knows. Because sometimes success comes with a price that no medal can compensate for. And sometimes the greatest innovations leave their creators behind in ways nobody expects. The war ended on August 15, 1945, and Eddie Carver was standing in his workshop in Dayton when he heard the news. 53 years old by then, his hair graying, his hands still stained with metal dust from a lifetime of machining work. The factory erupted in celebration. Workers cheered, embraced, wept with relief. Eddie joined the celebration but felt strangely disconnected, as if watching from a distance. For 2 years, his entire existence had focused on one thing: making sure American soldiers had equipment they could trust. Now that purpose had suddenly evaporated. The Army Ordnance Facility in Dayton began winding down operations almost immediately. Military contracts were canceled. Production quotas dropped sharply. Workers who'd been classified as essential war industry personnel just weeks earlier now faced uncertain futures. The factory that had employed over 3,000 people during peak wartime production would be down to a skeleton crew by Christmas. Eddie received notice in September that his position would be eliminated effective December 1, 1945. He'd get a modest severance and a commendation letter thanking him for his wartime service. Then he'd be on his own to find work in a suddenly crowded job market flooded with returning veterans and displaced war workers. Helen took the news with characteristic pragmatism. "We've saved money," she reminded him. "You'll find another job. You're too skilled not to." But Eddie wasn't worried about employment. He was struggling with a different problem. For 2 years, he'd been the man who'd revolutionized sniper rifle accuracy, who'd defied bureaucracy and saved lives through sheer stubborn determination. Now, he was just another unemployed machinist in a city full of them. The meritorious Civilian Service Medal sat in a drawer at home. The commendation letters were filed away. Nobody at the unemployment office cared that he'd changed military history. Marcus came home in October 1945, thinner than Eddie remembered, with a distant look in his eyes that suggested he'd seen things he'd never talk about. The two men met at Eddie's house on a cool autumn evening, sitting in the backyard with beers, not saying much at first. Finally, Marcus spoke. "I heard about what you did. The scope mounts. The other guys in my unit, the ones who made it home, they wanted me to thank you personally. We trusted those rifles because of you." Eddie waved off the gratitude, uncomfortable with praise. "I just did what needed doing." "No," Marcus said firmly. "You did what nobody else would do. You broke the rules because it was right. That takes a different kind of courage than what we had in combat. I'm not sure I could have done it." The two men sat in silence for a while, each understanding something about the other that didn't need words. They'd both fought the war in different ways, both took risks that could have destroyed them, both did what they believed was right despite the cost. That shared understanding meant more than any medal. Eddie found work in early 1946 at an automotive plant in Detroit, making parts for civilian cars instead of military rifles. The pay was decent, the work familiar, but something had changed. Eddie couldn't stop thinking about problems, questioning designs, seeing ways to improve manufacturing processes. But this time, when he suggested modifications to his new supervisors, they actually listened. His wartime reputation had followed him, and the plant manager specifically hired him because of his record of innovation. For the next 20 years, Eddie worked in automotive manufacturing, quietly improving processes, training younger machinists, passing on the lessons he'd learned. He never sought publicity or recognition. When a military history researcher tried to interview him in 1963 about the scope mounting modification, Eddie politely declined. "The work speaks for itself," he said. "I don't need credit, just satisfaction that it helped." Helen passed away in 1968 after a brief illness, and Eddie retired shortly after, unable to imagine continuing without her partnership and support. He spent his final years in a small house in Dayton, maintaining a workshop in his garage, where he tinkered with various projects and occasionally mentored young people interested in machining trades. But Eddie's legacy extended far beyond his personal story, reaching into military technology development for decades after the war ended. The tension groove modification became standard on American military rifle scopes, incorporated into designs for the M1 Garand, the M14, and eventually the M16 rifle systems. Each new weapon platform inherited the principle Eddie had discovered: controlled flexibility absorbs shock better than rigid strength. In Korea, from 1950 to 1953, American snipers equipped with rifles using Eddie's mounting design reported similar accuracy advantages over enemy forces. Chinese and North Korean troops learned the hard way that American long-range fire was devastatingly precise, forcing them to modify tactics and increasing their defensive requirements significantly. In Vietnam, the principle evolved further. Engineers developed more sophisticated mounting systems, incorporating multiple tension relief points and advanced materials. But the fundamental insight remained Eddie's. Military studies estimated that scope mounting improvements contributed to a 340% increase in sniper effectiveness between 1945 and 1975, with Eddie's original modification identified as the foundational innovation. Other nations copied and adapted the design. Soviet weapons engineers incorporated similar tension relief concepts into their SVD Dragunov sniper rifle in 1963. British, German, and Israeli military forces all adopted variations of the controlled flex mounting principle. By the 1980s, every major military in the world used scope mounting systems based at least partially on the concept an Ohio machinist had hand-filed into steel rings in 1944. The civilian hunting and sporting rifle market adopted the technology as well. Commercial scope manufacturers began producing mounts with tension relief features advertising improved accuracy and durability. Millions of civilian hunters benefited from a modification originally developed for military snipers, though few knew its origin story. Statistical analysis conducted by the Army in 1985 attempted to quantify Eddie's total impact. The study estimated that the scope mounting modification, combined with its derivative improvements and applications, had contributed to approximately 15,000 to 20,000 successful sniper engagements across various conflicts from 1944 to 1985. Each engagement potentially saved multiple friendly casualties by eliminating enemy threats at range. The conservative estimate suggested Eddie's innovation had saved between 30,000 and 50,000 American and Allied lives over 4 decades of military operations. Modern military rifles still incorporate the principle. The M110 semi-automatic sniper system, the M2010 enhanced sniper rifle, and other contemporary platforms use sophisticated mounting systems that trace their conceptual lineage directly back to Eddie's simple groove. Materials have changed from steel to advanced alloys and polymers. Manufacturing has progressed from hand filing to precision CNC machining. But the engineering principle remains identical. Create controlled flex points that absorb shock without allowing scope movement. In 2015, 70 years after the original modification, military historians finally gave Eddie's contribution its full due when the Army Ordnance Corps Museum at Aberdeen Proving Ground dedicated a permanent exhibit to his innovation, displaying one of the original hand-modified mounting rings alongside modern examples, and explaining the evolution of the technology. But the technical legacy, impressive as it was, represented only part of Eddie's impact. The deeper lesson had nothing to do with rifles or scopes or mounting rings. It was about innovation itself, about how breakthrough ideas emerge and why organizations often resist them. Eddie's story demonstrated that expertise doesn't require credentials, that someone with practical hands-on experience can sometimes see solutions that theoretically trained experts miss. The engineers who designed the original scope mounting system had advanced degrees and sophisticated understanding of ballistics and materials science. But they'd never spent 12-hour days examining thousands of rifle components, never developed the intimate tactile understanding of how metal behaves under stress that comes from years of machining work. Eddie's advantage wasn't superior intelligence or education. It was different perspective born from different experience. The story also revealed the inherent conservatism of large organizations, particularly military bureaucracies during wartime. The Army had protocols, procedures, and hierarchies designed to ensure quality control and prevent mistakes. Those systems served important purposes, but they also created barriers to innovation, especially innovation from unexpected sources. Eddie had to break rules and risk punishment because the official channels wouldn't accommodate his idea. That raised uncomfortable questions. How many other good ideas were rejected because they came from the wrong person or through the wrong channels? How many soldiers died because bureaucracy valued procedures over results? Eddie's willingness to act, despite the risks, set him apart. Lots of people have good ideas. Few have the courage to implement them without permission when everyone in authority says no. That combination of insight and audacity is rare and precious. Military history contains other examples of similar breakthroughs from unlikely sources. In World War I, a French wine merchant named Louis Breguet designed one of the most successful reconnaissance aircraft despite having no formal aviation training. During World War II, a British truck driver named Percy Hobart revolutionized tank warfare tactics that professional military strategists had dismissed as impractical. A civilian chemist named Chaim Weizmann developed a critical acetone production process that helped Britain manufacture munitions when military researchers had failed to solve the problem. These stories share common elements: unconventional thinkers' resistance from established authorities, breakthrough solutions that changed outcomes. The pattern suggests that innovation often requires outsider perspectives, people willing to challenge conventional wisdom and risk failure. In today's world, the same dynamics persist. Military organizations still struggle to incorporate innovations from unexpected sources. Corporate hierarchies still resist ideas that don't come from the right departments. Scientific establishments still dismiss theories that don't fit prevailing paradigms. Eddie Carver's story offers a template for navigating those barriers. Identify a real problem. Develop a practical solution. Test it rigorously, then implement it with or without official permission and accept the consequences. But there's one final detail about Eddie's story that almost nobody knows, a twist that adds poignant context to everything that came before. In 1982, military researchers declassified documents revealing that Eddie Carver wasn't the first person to think of the tension groove modification. An Army engineer named Robert Halstead had proposed an almost identical concept in 1939, 4 years before Eddie's unauthorized implementation. Halstead had written a detailed technical paper describing how controlled flex points in scope mounting rings could reduce vibration transmission and improve accuracy retention. His proposal included mathematical calculations, engineering drawings, and specific implementation recommendations. The Army Ordnance Department had reviewed Halstead's proposal and rejected it. The official rejection letter, dated March 1940, stated that the modification was unnecessary, given the adequate performance of existing scope mounting designs, would complicate manufacturing without sufficient benefit, and failed to justify the cost of retooling production facilities. Halstead had accepted the rejection and moved on to other projects. His idea died in a filing cabinet, forgotten. Eddie Carver succeeded where Robert Halstead failed, not because his idea was better or his engineering was more sophisticated. Eddie succeeded because he refused to accept no for an answer, because he was willing to break rules and risk everything to implement what he knew was right. That difference, that stubborn determination to act despite official rejection, made all the difference between a good idea that died in bureaucracy and an innovation that saved thousands of lives. The researchers who discovered Halstead's original proposal considered it a historical footnote, an interesting precedent, but ultimately irrelevant since Halstead never implemented his idea. But it raises profound questions about innovation and organizational behavior. How many Robert Halsteads are there in military history, or corporate history, or scientific history? How many people had the right answer but lacked the determination or the recklessness to push it through? Despite resistance. How many breakthrough innovations never happened because the first person to think of them accepted no when they should have ignored it? Eddie Carver died in 1992 at age 80, never knowing about Halstead's earlier proposal. He went to his grave believing he'd been the first to think of the tension groove modification. And in a sense, he was. Because having an idea means nothing if you don't act on it. Innovation isn't about being the first to think of something. It's about being the first to make it real, to push it through resistance and skepticism and bureaucracy until it exists in the world, rather than just on paper. Eddie made it real. That's why we remember his name and not Robert Halstead's. That's why his modification changed warfare, and Halstead's proposal gathered dust in a filing cabinet. The lesson is uncomfortable, but important. Being right isn't enough. You have to be right and stubborn and willing to risk everything on your convictions. That combination is rare, precious, and transformative. From a factory machinist with a stubborn streak to an innovation that shaped military technology for 7 decades. Eddie Carver's journey proves that breakthrough ideas can come from anywhere, and that courage sometimes means defying everyone who tells you to stay in your lane. His unauthorized modification saved an estimated 30,000 to 50,000 lives across multiple conflicts, shortened battles, and gave American forces tactical advantages they desperately needed. Not because he was the smartest person in the room or had the best credentials, but because he saw a problem that needed solving and refused to let bureaucracy stop him from solving it. He risked his job, his freedom, and his reputation on the conviction that a tiny groove filed into a piece of metal could make a difference. And he was right. That's the power of refusing to accept that problems are unsolvable just because the experts say so. That's the legacy of Edwin Carver, machinist innovator, and the man who proved that sometimes the most important qualification isn't education or authority. It's the stubborn courage to act when action is needed, rules be damned. His story reminds us that innovation doesn't always come from the top down, that the best solutions often come from the people closest to the problems, and that changing the world sometimes requires breaking the rules that prevent change. 70 years after Eddie first filed that groove into a scope mounting ring, his principle still protects soldiers in combat. And somewhere in workshops and factories and offices around the world, there's another Eddie Carver seeing a problem everyone else ignores, developing a solution everyone else dismisses, and deciding whether to have the courage to act without permission. This story is for them. Because the world needs more people who refuse to accept no when they know they're right, more people willing to risk everything on an idea that can save lives, more people with the courage to be Edwin Carver. That's how progress happens. That's how wars are won. That's how one civilian's stupid fix became the innovation that changed warfare forever.